Mercia Shabia Mofa is my name, and you are all welcome to today's robot design methodology class. Our main focus for the day is exploring features of selected modeling, programming, and simulation tools used for robot design. Okay, so by the end of the lesson, you will learn modeling tools, programming tools, and simulation tools. So you are going to explain all these tools. Then again, we identify common robot design software. And lastly, we explain why these tools matters. Okay, let's begin, students. So let's think of this exercise. So imagine you want to build a robot that helps an elderly person carry food from the market. So which of the options will you go for? Is it option A, which is build it immediately, or option B, which is design and test on your computer? I will give you 1 minute to think about it. All right. So someone will say option A, and the other will say option B. Let's all look at the correct answer. Okay, correct answer is option B, design and test on the computer. So learners, if you had this correct, I want you to tick yourself that you had it correct. And if you had it correct, congratulations. If you had it wrong, there is also another exercise coming. So try and also get that one correct. Now let's move on to robot design. Robot design. So what exactly is robot design? Robot design is the process of planning, creating, testing and improving a robot before building the real one. It's a cycle of thinking, making and refining. We first develop the idea, then we design, we program the robots, then again we test the robots, then again we build the robots. So you go through all these steps and we will take a look at the tools we are going to use to complete each of the steps. So we will move on to robot design tools. So to complete those steps we talk about, we use robot design tools to complete them. So robot design tools are computer applications that helps engineers design, program, test and improve robots. So in designing, engineers use robot design to create digital models of robots, parts and assemblies. Then again, in writing of programs, engineers give robot instruction using code or visual blocks. In testing the behavior of the robots, it is used to run virtual experiments to see how the robots respond. Then lastly, in improving performance too, engineers use these robot design tools to refine and optimize the robot before building it. Okay, so we will look at the 3 robot design tools. So it is categorized into 3. The first category is modeling tools. The second one is programming tools. And the third one is simulation tools. So in the course of the lesson, we are going to cover all these three tools. We will begin with modeling tools. Modeling tools are software applications used to create digital 3D model of a robot. Popular examples of modeling tools are Tinkercad, Fusion 360, SolidWorks, and Bricklist Studio. Modeling tools have some key features. We have 3D design and visualization, and also virtual prototyping. So you can take a look at the interface of the 3D design. So this whole interface is a Tinkercad interface, and this is the 3D modeling. 3D modeling. So instead of drawing on a paper, with the modeling tools, we draw on the computer in 3D version. Okay, we will move on to programming tools. Programming tools let engineers write the instruction that controls the robot behaviors. So popular examples of programming tools are Arduino IDE, Lego Spike, EV3 Classroom, and Visual Studio Code. Its key features are code editor with syntax highlighting, then error checking and debugging, and also upload code to the robot. Alright, students, let's talk about one important thing here, which is IDE. I know some of you might already know this. IDE. So I want you to write the full form of IDE for me. IDE. Okay, 3 seconds more. Alright, so let's all look at the full form of IDE. IDE. Okay, so as you can see, IDE stands for Integrated Development Environment. So if you had this one correct too, take yourself. You have 5 points. Okay, so an IDE is a single software application that combines everything a programmer needs to write, test, and fix robot programs. So IDE is used to write code. It's used to edit code, find errors, upload programs, and test programs too. Now we will move on to simulation tools. Simulation tools. Simulation tools let engineers test robots in a virtual environment. No physical part is needed. Some popular examples are Gazebo, Weebots, and Virtual Robotics Toolkits. Okay. Now, let's take a look at 5 reasons to simulate first. So, someone might ask, why all this? Why do we need to simulate? So, one is simulation saves money. Simulation prevents damage. It saves time. It helps engineers also find mistakes early. Then again, it helps engineers improve performance. Alright, now let's go into deeper in Tinkercad. So Tinkercad is a free browser-based tool for designing robots and electronic circuits. No installation needed. It's very simple to use. So you can quickly open Tinkercad free in any web browser and start creating the robots. So key features of the Tinkercad is drag and drop, then 3D modeling for robot parts, then Arduino circuit simulation, and also it's great for beginners. So as I said earlier, it's very simple to use. So most of the engineers use Tinkercad. So this is also an interface of Tinkercad, as we already saw in our previous slides. So interface of Tinkercad. Okay. Now we also talk about the Arduino IDE. Arduino IDE is the go-to software for programming Arduino boards, the brain behind many beginner robots. It's used to write code, it's used to check errors, and it's also used to upload the codes directly to your robots. It's used to upload the code directly to your robots. Alright, now there is some class activity I want you to participate. So think about each task below. Which software tool would you use? Which software tool would you use? Alright, which software would you use for these three activity? One is design a robot, write robot code, and test robot improvements. Design a robot. Let's say you need to create the shape and structure of a new robot. Which tool are you going to use? Let's say you need to program an Arduino board to control motors and sensors. Which tool are you going to use then? If you want to see how your robot behaves in a virtual environment, which tool are you going to use? So I want you to think of it, then get me the correct answers. Okay, so what have we learned today? What have we learned today? So today we learned that robot design starts with planning. Modeling tools create digital version of robots. Programming tools write the robot instruction, and simulation tools test robots safely and cheaply. Then we also discover the 5 steps before you can come up with the actual robot. We said that you need to develop an idea, you need to model or design it in a Tinkercad, then program it, then also simulate it, then again build the actual or the real robot. So this brings us to an end of the class. Okay, great job today, my learners.